Okay, last year 4% of cars tested in a large chain of garages failed an emissions test. A random sample of n of these cars is taken. The number of cars that failed a test is represented by x. Given that the standard deviation of x is 1.44, find the value of n and also find the expectation. Okay, so this has all the hallmarks of a binomial distribution. We have the probability here, which is going to be a fixed probability. We have n trials or n observations or n in us, or we have a sample size of n. So from there we should be able to state a binomial distribution. Okay, so the only unknown here is n, and that's what we're going to try and find. But I have been told the standard deviation is 1.44. All right, so the standard deviation we know is related to the variance, and we can easily calculate the variance from the binomial distribution. So sigma equals the square root of the variance of x, and variance of x is n times p times q. So I should be able to undo this to figure out what n is. So substituting in the values that we know the standard deviation is 1.44. That's going to be the square root. N we don't know, but p we've been told, and from there we can figure out q must be 0.96. All right, square both sides and multiply by 0.04 and 0.96. That should get us our value for n. Okay, so square both sides and then divide by 0.04 and 0.96, and that should get you our value for n. All right, and from there, n equals 54. Okay, we're also asked to find the expectation. Expectation for a binomial distribution is just np. So now that I've got my value of n, let's just multiply through, and we get an answer of 2.16. All right, so the value of n and the expectation. So just that little extra bit of knowledge that from the binomial distribution we can find the expectation and the variance, so therefore the standard deviation as well. Okay, so a random sample of 20 of the cars is tested. Find the probability that all of the cars pass the emissions test. So we're working with a new distribution now. X follows a binomial. It's 20 trials now and 0.04. Find the probability that all of the cars passed the emission test. So that actually means none of them failed. Remembering that X was a distribution of how many cars failed. So the probability that X equals 0, probability that there's no failures, 20C0, 0.04 to the power of 0. Both of these are a little bit redundant since they're both equal 1, and 0.96 to the power of 20. And that gets us our answer of 0.4420. Okay, you might have seen it straight away that we only really needed to do 0.96 to the power of 20. Okay, so now we have, so moving on, given that at least one of these cars failed the emissions test, find the probability that exactly 3 of these cars failed the emissions tests. Okay, so we've got a given statement thrown in, and as soon as we see that, we should recall our formula. Probability of A given B is going to equal the intersection of the 2 divided by the probability of B. In this case, we just need to decide what is A, what is B. The given is always the second part, so B is the probability that at least one of the cars failed, and A is going to be the probability that exactly 3 of the cars failed. Okay, the intersection of at least 1 and exactly 3 is going to be the 3 anyway, since having 3 fail is automatically at least 1. So let's find those 2 probabilities. Probability of exactly 3, I'm going to state those separately over here. So those just going into the probability function, 20C3, 0.04 to the power of 3, and 0.96 to the power of 17. So that's the probability of exactly 3, and B we decided was at least 1, so that's the probability that X is greater than or equal to 1. For that we can do 1 minus the probability that X is less than or equal to 0. That's the same as equals 0. We had that in part B of the question, so I'm looking for 1 minus 0.4420, which equals 0.5580. All right, perfect. These are the 2 things that I wanted, so I can substitute them into this expression over here. So the probability that X equals 3 divided by the probability that X is greater than or equal to 1. 0.0653 to 4 decimal places. Okay, just be careful to make sure that you're using the exact values when you're calculating. So here, this numerator should really be that whole statement, so we don't lose any accuracy on this final answer. Okay, so a car mechanic claims that more than 4% of cars tested at the garage chain this year are failing the emissions test. A random sample of 125 of these cars is taken and 10 of these fail the emissions test. Using a suitable approximation, test whether or not there's evidence to support the mechanic's claim. Use a 5% level of significance and state your hypotheses. Alright, straight away we know we're meant to be using a suitable approximation. I'm starting in the binomial, so I'm potentially going to the Poisson or to the normal. Let's pull out some more from the question. So the mechanics claim that more than 4% are failing their test. The sample size is 125, and our test statistic, which we'll come back to later, is 10. Okay, so the hypothesis test, X for HO, probability equals 0.04, and this is the claim, this is the mechanics claim, that is going to be more than 0.04. For the null hypothesis, we're saying that X follows a binomial, where N is 125, and P is 0.04. So straight away, that N value is too large for me to use the binomial. Is it Poisson or is it going to be the normal? Well, the conditions for the Poisson is that N is large and P is small. The conditions for the normal is that N is large and P is close to 0.5. This looks like it's going to be the Poisson. If the expectation that I get doesn't or won't work with the Poisson, then I have no choice but to go to the normal distribution. Let's see what happens. So the expectation, 125 times 0.04, that leaves us with 5. Actually, that will be perfect for the Poisson distribution. So the approximation is to approximate to the Poisson. Okay, so we're going to go ahead and say that X can also follow a Poisson of 5. Okay, let's work with our test statistic, which is the 10. Okay, let's not forget the significance level, which was 5%. Just a quick sketch to make sure that we're on the right track. Expectation is 5, and we're testing whether or not we may well end up over here in the rejection region with a critical value, or in the rejection region, or with a value that is in the critical region. Okay, so let's get down to the actual test. 10 was more than we were expecting, so I'm going to go for greater than or equal to 10. Our tables are not set up for greater than probabilities, so straight away I need to do a 1 minus. 1 minus the probability that X is less than or equal to 9. 1 minus 0.9682, and that's going to be 0.0318. Okay, how does that compare to the significance level? 0.0318 is less than 5%. If I was to sketch it on the diagram, it's only going to take up this much space. It's fully contained within the critical region. This is a significant result, okay? And that's going to lead to our conclusions. Okay, so firstly, this is a significant result. I'm going to have enough evidence to reject H0. Okay, and then in context, what's my conclusion? Remembering that the mechanics claim was actually H1. So there is actually enough evidence to support the mechanics claim that the proportion of cars that were failing their emissions test is actually greater than 0.05. Okay, so there is enough evidence to reject H0, and there is enough evidence to support the mechanics claim that the proportion of cars that are failing their emissions test is greater than 0.04. Okay, both of those statements, well placed and set out work each step of the way, is what you're going to need to present to get all of your marks.